Any operator who wishes to adopt a manufacturer's inspection program should first contact their local FAA Flight Standards District Office for further guidance. Altimeter and static system inspections in accordance with 14 CFR Part 91, Section 91.411. Any person operating an airplane or helicopter in controlled airspace under Instrument Flight Rules, IFR, must have had, within the preceding 24 calendar months, each static pressure system, each altimeter instrument, and each automatic pressure altitude reporting system tested and inspected and found to comply with 14 CFR Part 43, Appendix E. Those tests and inspections must be conducted by appropriately rated persons under 14 CFR. Air Traffic Control, ATC, Transponder inspections. Any person using an air traffic control, ATC, transponder must have had, within the preceding 24 calendar months, that transponder tested and inspected and found to comply with 14 CFR Part 43, Appendix F, and Part 91, Section 91.411. Additionally, following any installation or maintenance on an ATC transponder where data correspondence error could be introduced, the integrated system must be tested and inspected and found to comply with 14 CFR Part 43, Appendix E, and Part 91, Section 91.411 by an appropriately rated person under 14 CFR. Emergency Locator Transmitter, ELT, Operational and Maintenance Practices in accordance with Advisory Circular, AC, 91-44. This AC combined and updated several ACs on the subject of ELTs and receivers for airborne service. Under the operating rules of 14 CFR Part 91, most small U.S. registered civil airplanes equipped to carry more than one person must have an ELT attached to the airplane. 14 CFR Part 91, Section 91.207 defines the requirements of what type aircraft and when the ELT must be installed. It also states that an ELT that meets the requirements of Technical Standard Order, TSO, C91 may not be used for new installations. The pilot in command of an aircraft equipped with an ELT is responsible for its operation and, prior to engine shutdown at the end of each flight, should tune the VHF receiver to 121.5 MHz and listen for ELT activations. Maintenance personnel are responsible for accidental activation during the actual period of their work. Maintenance of ELTs is subject to 14 CFR Part 43 and Part 91, Section 91.413, and should be included in the required inspections. It is essential that the impact switch operation and the transmitter output be checked using the manufacturer's instructions. Testing of an ELT prior to installation or for maintenance reasons should be conducted in a metal enclosure in order to avoid outside radiation by the transmitter. If this is not possible, the test should be conducted only within the first 5 minutes after any hour. Manufacturers of ELTs are required to mark the expiration date of the battery, based on 50% of the useful life, on the outside of the transmitter. The batteries are required to be replaced on that date or when the transmitter has been in use for more than one cumulative hour. Water-activated batteries have virtually unlimited shelf life. They are not usually marked with an expiration date. They must be replaced after activation regardless of how long they were in service. The battery replacement can be accomplished by a pilot on a portable type ELT that is readily accessible and can be removed and reinstalled in the aircraft by a simple operation. That would be considered preventive maintenance under 14 CFR Part 43, Section 43.3, G. Replacement batteries should be approved for the specific model of ELT and the installation performed in accordance with Section 43.13. AC 91-44 also contains additional information on 1. Airborne homing and alerting equipment for use with ELTs. 2. Search and rescue responsibility. 3. Alert and search procedures including various flight procedures for locating an ELT. 4. The FAA Frequency Management Offices, for contacting by manufacturers when they are demonstrating and testing ELTs. Although there is no regulatory requirement to install a 406 ELT, the benefits are numerous, regardless of regulatory minimums. All new installations must be a 406 MHz digital ELT. It must meet the standards of TSO C126. When installed, the new 406 MHz ELT should be registered so that if the aircraft were to go down, search and rescue could take full advantage of the benefits the system offers. The digital circuitry of the 406 MHz ELT can be coded with information about the aircraft type, base location, ownership, etc. This coding allows the search and rescue (SAR) coordinating centers to contact the registered owner or operator if a signal is detected to determine if the aircraft is flying or parked. This type of identification permits a rapid SAR response in the event of an accident, and will save valuable resources from a false alarm search. End of page 2-61. Annual and 100-hour inspections preparation. An owner/operator bringing an aircraft into a maintenance facility for an annual or 100-hour inspection may not know what is involved in the process. This is the point at which the person who performs the inspection sits down with the customer to review the records and discuss any maintenance issues, repairs needed, or additional work the customer may want done. Moreover, the time spent on these items before starting the inspection usually saves time and money before the work is completed. The work order describes the work that will be performed and the fee that the owner pays for the service. It is a contract that includes the parts, materials, and labor to complete the inspection. It may also include additional maintenance and repairs requested by the owner or found during the inspection. Additional materials such as ADs, manufacturer's service bulletins and letters, and vendor service information must be researched to include the avionics and emergency equipment on the aircraft. The TCDS provides all the components eligible for installation on the aircraft. The review of the aircraft records is one of the most important parts of any inspection. Those records provide the history of the aircraft. The records to be kept and how they are to be maintained are listed in 14 CFR Part 91, Section 91.417. Among those records that must be tracked are records of maintenance, preventive maintenance, and alteration, records of the last 100-hour, annual, or other required or approved inspections for the airframe, engine propeller, rotor, and appliances of an aircraft. The records must include 1. A description, or reference to data acceptable to the FAA, of the work performed. 2. The date of completion of the work performed and the signature and certificate number of the person approving the aircraft for return to service. 3. The total time and service and the current status of life-limited parts of the airframe, each engine, each propeller, and each rotor. 4. The time since the last overhaul of all items installed on the aircraft which are required to be overhauled on a specified time basis. 5. The current inspection status of the aircraft, including the time since the last inspection required by the program under which the aircraft and its appliances are maintained. 6. The current status of applicable ADs including for each, the method of compliance, the AD number, and revision date. If the AD involves recurring action, the time and date when the next action is required. 7. Copies of the forms prescribed by 14 CFR Part 43, Section 43.9, for each major alteration to the airframe and currently installed components. The owner/operator is required to retain the records of inspection until the work is repeated, or for 1 year after the work is performed. Most of the other records that include total times and current status of life-limited parts, overhaul times, and AD status must be retained and transferred with the aircraft when it is sold. 14 CFR Part 43, Section 43.15 requires that each person performing a 100-hour or annual inspection shall use a checklist while performing the inspection. The checklist may be one developed by the person, one provided by the manufacturer of the equipment being inspected, or one obtained from another source. The checklist must include the scope and detail of the items contained in Part 43, Appendix D. The inspection checklist provided by the manufacturer is the preferred one to use. The manufacturer separates the areas to inspect such as engine, cabin, wing, empennage, and landing gear. They typically list service bulletins and service letters for specific areas of the aircraft and the appliances that are installed. Initial run-up provides an assessment to the condition of the engine prior to performing the inspection. The run-up should include full power and idle RPM, magneto operation, including positive switch grounding, fuel mixture check, oil and fuel pressure, and cylinder head and oil temperatures. After the engine run, check it for fuel, oil, and hydraulic leaks. Following the checklist, The entire aircraft shall be opened by removing all necessary inspection plates, access doors, fairings, and cowling. The entire aircraft must then be cleaned to uncover hidden cracks or defects that may have been missed because of the dirt. Following in order and using the checklist, visually inspect each item, or perform the checks or tests necessary to verify the condition of the component or system. Record discrepancies when they are found. The entire aircraft should be inspected and a list of discrepancies be presented to the owner. A typical inspection following a checklist on a small single-engine airplane may include in part, as applicable: 1. The fuselage for damage, corrosion, and attachment of fittings, antennas, and lights, for smoking rivets, especially in the landing gear area, indicating the possibility of structural movement or hidden failure. End of page 2 to 62. 2. The flight deck and cabin area for loose equipment that could foul the controls, seats and seat belts for defects and TSO tags, windows and windshields for deterioration, instruments for condition, markings, and operation, flight and engine controls for proper operation. 3. The engine and attached components for visual evidence of leaks, studs and nuts for improper torque and obvious defects, engine mount and vibration dampeners for cracks, deterioration, and looseness, engine controls for defects, operation, and safetying, the internal engine for cylinder compression, spark plugs for operation, oil screens and filters for metal particles or foreign matter, exhaust stacks and mufflers for leaks, cracks, and missing hardware, cooling baffles for deterioration, damage, and missing seals, and engine cowling for cracks and defects. For the landing gear group for condition and attachment, shock-absorbing devices for leaks and fluid levels, retracting and locking mechanism for defects, damage, and operation, hydraulic lines for leakage, electrical system for chafing and switches for operation, wheels and bearings for condition, tires for wear and cuts, and brakes for condition and adjustment. 5. The wing and center section assembly for condition, skin deterioration, distortion, structural failure, and attachment. 6. The empennage assembly for condition, distortion, skin deterioration, evidence of failure, smoking rivets, secure attachment, and component operation and installation. 7. The propeller group and system components for torque and proper safetying, the propeller for nicks, cracks, and oil leaks, the anti-icing devices for defects in operation, and the control mechanism for operation, mounting, and restricted movement. 8. The radios and electronic equipment for improper installation and mounting, wiring and conduits for improper routing, insecure mounting, and obvious defects, bonding and shielding for installation and condition, and all antennas for condition, mounting, and operation. Additionally, if not already inspected and serviced, the main battery inspected for condition, mounting, corrosion, and electrical charge. 9. Any and all installed miscellaneous items and components that are not otherwise covered by this listing for condition and operation. With the aircraft inspection checklist completed, the list of discrepancies should be transferred to the work order. As part of the annual and 100-hour inspections, the engine oil is drained and replaced because new filters and/or clean screens have been installed in the engine. The repairs are then completed and all fluid systems serviced. Before approving the aircraft for return to service after the annual or 100-hour inspection, 14 CFR states that the engine must be run to determine satisfactory performance in accordance with the manufacturer's recommendations. The run must include: 1. Power output, static and idle RPM. 2. Magnetos, for drop and switch ground. 3. Fuel and oil pressure. 4. Cylinder and oil temperature. After the run, the engine is inspected for fluid leaks and the oil level is checked a final time before close-up of the cowling. With the aircraft inspection completed, all inspections plates, access doors, fairing and cowling that were removed must be reinstalled. It is a good practice to visually check inside the inspection areas for tools, shop rags, etc., prior to close-up. Using the checklist and discrepancy list to review areas that were repaired will help ensure the aircraft is properly returned to service. Upon completion of the inspection, the records for each airframe, engine, propeller, and appliance must be signed off. The record entry in accordance with 14 CFR Part 43, Section 43.11, must include the following information. 1. The type inspection and a brief description of the extent of the inspection. 2. The date of the inspection and aircraft total time in service. 3. The signature, the certificate number, and kind of certificate held by the person approving or disapproving for return to service the aircraft, airframe, aircraft engine, propeller, appliance, component part, or portions thereof. 4. For the annual and 100-hour inspection, if the aircraft is found to be airworthy and approved for return to service, enter the following statement: I certify that this aircraft has been inspected in accordance with that insert type inspection and was determined to be in airworthy condition. 5. If the aircraft is not approved for return to service because of necessary maintenance, non-compliance with applicable specifications, airworthiness directives, or other approved data, enter the following statement: I certify that this aircraft has been inspected in accordance with that insert type inspection, and a list of discrepancies and unairworthy items has been provided to the aircraft owner or operator. End of page 2 to 63. If the owner or operator did not want the discrepancies and/or unairworthy items repaired at the location where the inspection was accomplished, they may have the option of flying the aircraft to another location with a special flight permit, ferry permit. An application for a special flight permit can be made at the local FAA FSDO. Other aircraft inspection and maintenance programs. Aircraft operating under 14 CFR Part 135, commuter and on-demand, have additional rules for maintenance that must be followed beyond those in 14 CFR Parts 43 and 91. 14 CFR Part 135, Section 135.411 describes the applicable sections for maintaining aircraft that are type certificated for a passenger seating configuration, excluding any pilot seat, of 9 seats or less, and which sections are applicable to maintaining aircraft with 10 or more passenger seats. The following sections apply to aircraft with 9 seats or less. 1. Section 135.415 requires each certificate holder to submit a service difficulty report whenever they have an occurrence, failure, malfunction, or defect in an aircraft concerning the list detailed in this section of the regulation. 2. Section 135.417 requires each certificate holder to mail or deliver a mechanical interruption report for occurrences in multi-engine aircraft concerning unscheduled flight interruptions and the number of propeller featherings in flight, as detailed in this section of the regulation. 3. Section 135.421 requires each certificate holder to comply with the manufacturer's recommended maintenance programs, or a program approved by the FAA for each aircraft, engine, propeller, rotor, and each item of emergency required by 14 CFR Part 135. This section also details requirements for single-engine IFR passenger carrying operations. 4. Section 135.422. This section applies to multi-engine airplanes and details requirements for aging airplane inspections and records review. It excludes airplanes in schedule operations between any point within the state of Alaska. Any certificated operator using aircraft with 10 or more passenger seats must have the required organization and maintenance programs, along with competent and knowledgeable people to ensure a safe operation. Title 14 of the CFR, Sections 135.423 through 135.443 are numerous and complex, and compliance is required. However, they are not summarized in this handbook. It is the responsibility of the certificated operator to know and comply with these and all other applicable requirements of 14 CFR, and they should contact their local FAA FSDO for further guidance. The Approved Aircraft Inspection Program, AAIP, is an FAA-approved inspection program for aircraft of 9 or less passenger seats operated under 14 CFR Part 135. The AAIP is an operator-developed program tailored to their particular needs to satisfy aircraft inspection requirements. This program allows operators to develop procedures and time intervals for the accomplishment of inspection tasks in accordance with the needs of the aircraft, rather than repeat all the tasks at each 100-hour interval. The operator is responsible for the AAIP. The program must encompass the total aircraft, including all avionics equipment, emergency equipment, cargo provisions, etc. FAA Advisory Circular 135-10, as revised, provides detailed guidance to develop an approved aircraft inspection program. The following is a summary, in part, of elements that the program should include. 1. A schedule of individual tasks, inspections, or groups of tasks, as well as the frequency for performing those tasks. 2. Work forms designating those tasks with a sign-off provision for each. The forms may be developed by the operator or obtained from another source. 3. Instructions for accomplishing each task. These tasks must satisfy 14 CFR Part 43, Section 43.13a, regarding methods, techniques, practices, tools, and equipment. The instructions should include adequate information in a form suitable for use by the person performing the work. 4. Provisions for operator-developed revisions to referenced instructions should be incorporated in the operator's manual. 5. A system for recording discrepancies and their correction. 6. A means for accounting for work forms upon completion of the inspection. These forms are used to satisfy the requirements of 14 CFR Part 91, Section 91.417, so they must be complete, legible, and identifiable as to the aircraft and specific inspection to which they relate. 7. Accommodation for variations in equipment and configurations between aircraft in the fleet. 8. Provisions for transferring an aircraft from another program to the AAIP. The development of the AAIP may come from one of the following sources. End of page 2 to 64. 1. An adoption of an aircraft manufacturer's inspection in its entirety. However, many aircraft manufacturers' programs do not encompass avionics, emergency equipment, appliances, and related installations that must be incorporated into the AAIP. The inspection of these items and systems will require additions to the program to ensure they comply with the air carrier's operation specifications and is applicable to 14 CFR. 2. A modified manufacturer's program. The operator may modify a manufacturer's inspection program to suit its needs. Modifications should be clearly identified and provide an equivalent level of safety to those in the manufacturer's approved program. 3. An operator-developed program. This type of program is developed in its entirety by the operator. It should include methods, techniques, practices, and standards necessary for proper accomplishment of the program. 4. An existing progressive inspection program, 14 CFR Part 91.409d, may be used as a basis for the development of an AAIP. As part of this inspection program, the FAA strongly recommends that a corrosion protection control program and a supplemental structural inspection type program be included. A program revision procedure should be included so that an evaluation of any revision can be made by the operator prior to submitting them to the FAA for approval. Procedures for administering the program should be established. These should include defining the duties and responsibilities for all personnel involved in the program, scheduling inspections, recording their accomplishment, and maintaining a file of completed work forms. The operator's manual should include a section that clearly describes the complete program, including procedures for program scheduling, recording, and accountability for continuing accomplishment of the program. This section serves to facilitate administration of the program by the certificate holder and to direct its accomplishment by mechanics or repair stations. The operator's manual should include instructions to accomplish the maintenance/inspections tasks. It should also contain a list of the necessary tools and equipment needed to perform the maintenance and inspections. The FAA FSDO will provide each operator with computer-generated operations specifications when they approve the program. Continuous Airworthiness Maintenance Program, CAMP. The definition of maintenance in 14 CFR Part 1 includes inspection. The inspection program required for 14 CFR Part 121 and Part 135 air carriers is part of the Continuous Airworthiness Maintenance Program, CAMP. CAMP is not required of every Part 135 carrier, it depends on aircraft being operated. It is a complex program that requires an organization of experienced and knowledgeable aviation personnel to implement it. The FAA has developed an advisory circular, AC 120-16, as revised, Air Carrier Maintenance Programs, which explains the background as well as the FAA regulatory requirements for these programs. The AC applies to air carriers subject to 14 CFR Parts 119, 121, and 135. For Part 135, it applies only to aircraft type certificated with 10 or more passenger seats. Any person wanting to place their aircraft on this type of program should contact their local FAA FSDO for guidance. Title 14 CFR Part 125, Section 125.247, Inspection Programs and Maintenance. This regulation applies to airplanes having a seating capacity of 20 or more passengers or a maximum payload capacity of 6,000 pounds or more when the aircraft is not required to be operated under 14 CFR Parts 121, 129, 135, and 137. Inspection programs which may be approved for use under this 14 CFR part include, but are not limited to: 1. A continuous inspection program which is part of a current continuous airworthiness program approved for use by a certificate holder under 14 CFR Part 121 or Part 135. 2. Inspection programs currently recommended by the manufacturer of the airplane, airplane engines, propellers, appliances, or survival and emergency equipment, or 3. An inspection program developed by a certificate holder under 14 CFR Part 125. The airplane subject to this part may not be operated unless the replacement times for life-limited parts specified in the aircraft type certificate datasheets or other documents approved by the FAA are complied with. B. Defects disclosed between inspections, or as a result of inspection, have been corrected in accordance with 14 CFR Part 43, and C. The airplane, including airframe, aircraft engines, propellers, appliances, and survival and emergency equipment, and their component parts, is inspected in accordance with an inspection program approved by the FAA. End of page 2-65. These inspections must include at least the following: 1. Instructions, procedures and standards for the particular make and model of airplane, including tests and checks. The instructions and procedures must set forth in detail the parts and areas of the airframe, aircraft engines, propellers, appliances, and survival and emergency equipment required to be inspected. 2. A schedule for the performance of the inspections that must be performed under the program, expressed in terms of the time and service, calendar time, number of system operations, or any combination of these. 3. The person used to perform the inspections required by 14 CFR Part 125 must be authorized to perform maintenance under 14 CFR Part 43. The airplane subject to Part 125 may not be operated unless the installed engines have been maintained in accordance with the overhaul periods recommended by the manufacturer or a program approved by the FAA. The engine overhaul periods are specified in the inspection programs required by 14 CFR Part 125, Section 125.247. Piston-engine and turbine-powered helicopter inspections. A piston-engine helicopter must be inspected in accordance with the scope and detail of 14 CFR Part 43, Appendix D for an annual inspection. However, there are additional performance rules for inspections under 14 CFR Part 43, Section 43.15, requiring that each person performing an inspection under 14 CFR Part 91 on a rotorcraft shall inspect these additional components in accordance with the maintenance manual or instructions for continued airworthiness of the manufacturer concerned. 1. The drive shaft or similar systems. 2. The main rotor transmission gearbox for obvious defects. 3. The main rotor and center section, or the equivalent area. 4. The auxiliary rotor. The operator of a turbine-powered helicopter can elect to have it inspected under 14 CFR Part 91, Section 91.409. 1. Annual inspection. 2. 100-hour inspection, when being used for compensation or hire. 3. A progressive inspection, when authorized by the FAA. For an inspection program listed under 14 CFR Part 91, Section 91.409, F, when selected by the owner/operator and the selection is recorded in the aircraft maintenance records, 14 CFR Part 91, Section 91.409, E. When performing any of the above inspections, the additional performance rules under 14 CFR Part 43, Section 43.15, for rotorcraft must be complied with. Light sport aircraft and aircraft certificated as experimental. Light sport aircraft and aircraft that are certificated in the experimental category are issued a special airworthiness certificate by the FAA. Operating limitations are issued to these aircraft as a part of the special airworthiness certificate that specify the required inspections and inspection intervals for the aircraft. Typically, the operating limitations issued to these aircraft require that a condition inspection be performed once every 12 months. If the aircraft is used for compensation or hire, e.g., towing a glider, flight training, then it must also be inspected each 100 hours. A condition inspection is equivalent to the scope and detail of an annual inspection, the requirements of which are outlined in 14 CFR Part 43, Appendix D. An NP or an appropriately rated repair station can perform the condition inspection on any of these aircraft. The FAA issues repairman certificates to individuals who are the builder of an amateur-built aircraft, which authorizes performance of the condition inspection. Additionally, repairman certificates can be issued to individuals for conducting inspections on light sport aircraft. There are 2 ratings available for light sport repairman certificate, each with different privileges as described in 14 CFR Part 65, Section 65.107, but both ratings authorize the repairman to conduct the annual condition inspection. The operating limitations issued to the aircraft also require that the condition inspection be recorded in the aircraft maintenance records. The following or similarly worded statement is used. End of page 2 to 66. I certify that this aircraft has been inspected on, insert date, per the, insert either, scope and detail of 14 CFR Part 43, Appendix D, or manufacturer's inspection procedures, and was found to be in a condition for safe operation. The entry will include the aircraft's total time in service, cycles if appropriate, and the name, signature, certificate number, and type of certificate held by the person performing the inspection. End of Chapter 2. Chapter 3 is coming soon.